Okay, so in this video I'm going to have a look at question 5 in the Junior Cert Higher Level Maths Paper 2 for 2018. The list below shows the time in minutes taken by 12 students to solve a maths problem. We've got to work out the range of the data. Now, the data is already in order here. It goes from 3 up to 15. So we've got to work out the range. Now, the range is just simply the highest minus the lowest. So the range in this particular case is 15 minus 3, so the range is 12 minutes. Second thing we have to work out here is the interquartile range. So the interquartile range means that we're going to come up the data a quarter of the way, and we're going to then come up the data 3/4 of the way, and we're going to subtract those two values. So what the interquartile range does is it takes out, if we had any extreme values here, it would take those out of the equation. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 pieces of data here. So we've got to come up a quarter of the way up from 12. So if we take 12 and we divide by 4, that'll give us 3. So the third number here is not our Q1. You've got, because 3 is a whole number, what you've got to do is take the third and the fourth number and get the average or the mean of those two. So we've got to take 6 and we've got to take 7. We've got to add them and divide by 2, and that gives us 6.5. And this is our what's called Q1. This is our lower quartile. This is our lower quartile. Okay, so let's take 12 and we've divided by 4. What we want to do is get 3/4 of 12. We want to come up along here 3/4 the way along here. So we want 3/4 of 12. Well, that's going to be 9. So again, because 9 is a whole number, we don't pick the 9th number, we pick the 9th and the 10th number. So the 9th number is 13, the 10th number is 14. We add those, divide by 2, and that gives us 13.5. And that's equal to, that's our Q3, or our upper quartile. That's our upper quartile. We want our interquartile range is going to be Q3 minus Q1. So you just subtract these two numbers that we got here. So in other words, it's going to be 13.5 minus 6.5, and that gives us 7. So 7 minutes is our interquartile range. So if we had any kind of extreme values here, we don't in this particular case, but if we had these numbers here, and let's say at the very end here, instead of 15 we had something like 45, that would be an extreme value. It's an unusual value. So the range that we worked out in part 1 here wouldn't really be an accurate value for the spread of the data. So what we would do is we would take that extreme value out of the equation and we would use interquartile range. So we would come down a quarter and go up a quarter and use interquartile range instead. As it turns out, there are no extreme values here, so we don't have to worry about that. Okay, so let's have a look at the next part of this question, which is part B. We're given 3 histograms here, and let's just have a look at these first of all. We have data that's kind of evenly spread across the histogram here. We have data that's kind of bunched up in the middle here. There aren't too many values at the lower end or the upper end. And histogram C here doesn't have too many pieces of data in the middle. Most of the data is very low or very high. So let's have a look at the question then. Each of the histograms above match one of the statements in the table below. Write A, B, or C in the correct places in the table to show which histogram matches each statement. So we're talking about interquartile ranges here. So the interquartile range is a quarter of the range, the interquartile range is a half of the range, the interquartile range is 3/4 of the range. Now, so we've got three values here. We've got a quarter, we've got a half, and we've got 3/4 of the range. Here. So now the range is going to be the highest value here minus the lowest value, the largest value minus the smallest one in each case. So the interquartile range then is where we come up a quarter and come down a quarter from the top and subtract those two values. So our lowest interquartile range would be this one here, this histogram B, because most of the data here is bunched towards the middle. So the interquartile range is going to be down towards the middle here. Here we would be moving the interquartile range out a little bit, and here the interquartile range is going to be out near the end. We're going to be using Q1 and Q3 here, which would be out near the ends of the histogram here, if you like, the data in the histogram. So really what we're going to do here is just simply write, we have a quarter, a half, and 3/4. So a quarter of the range is going to be here. This is going to be histogram B. This is going to be histogram, yeah, it's just ABC, so the one in the middle is B. So we're going to take B here, because this is the lowest fraction of the range. This is going to be the next one here, so this is A, and then 3/4 of the range, or most of the range here, relative to the other two, is going to be C. So it says here in part C here, justify your answer for histogram B. So this is histogram B here is this one here, where we picked the lowest fraction of the range. So let's just write out something here for that. You can see here if histogram B is the one where most of the data is near the center. There aren't too many pieces of data up here at the end, at either end. So let's write down something here for this question. So we're going to say the majority of the data is near the center. Compared to the other two histograms. So therefore, it will have a smaller interquartile range. Since Q1, the lower quartile, and Q3, the upper quartile, are closer together. Again, compared to the other two histograms. Okay, so maybe I overdid it a little bit here, but basically what I'm saying here is that Q1 and Q3 here are fairly close together for histogram B, compared to, for example, this one, where Q1 and Q3 are going to be out here somewhere, and they're not going to be quite as far as here, but certainly further out here than here. So that's really it for this question.